and our sponsor for this new division within Autodesk is Buzz. So he wanted to come here to explain to you the bigger picture of Autodesk's vision, the future of making things.
Good morning, everybody. Turn this on. Before I start, I do want to encourage everybody to ask questions or interrupt. Okay, so I think it's a lot better just to have a little bit of a dialogue. So if you think something I'm saying is nuts, tell me. If you think something's, don't say if it's good. But I'd like to hear your point of view on some of these things. Okay? We just got to turn it all on. While I'm waiting, I do want to congratulate Dwayne on this facility, the school, for sponsoring. It's pretty impressive. He walked me through the whole thing this morning. They're really amazing. Congratulations. Very impressive. If you can get PowerPoint to work, you can do anything. Okay, so I want to tackle the question of the future of making things, okay? And I'll give you a little background on what that's all about. Now, by introduction, my name is Buzz Kross. That's a nickname. It's a terrible name to grow up with, but it is what it is. I'm responsible for our mechanical business. Okay, so I'm based here in Portland, Oregon. Autodesk acquired my company, which was based here now about 20 years ago. Truth is, I thought I was going to stay about 3 years. 20 years later, I'm still here. So we're a pretty diverse company, which I'll talk about a little bit, and I'll tell you how Delcam and how Footwear fits into all this. Okay, so just a few stats about Autodesk. We have about 12 million active users of our software. And that's kind of our professional software. If you think about some of the other things we do, products like Sketchbook, it's more like 100 million in terms of extension. So these are sort of like our professional users, people who use products like our mechanical design tools, our AEC tools, et cetera. About 800,000 companies worldwide use our software. We graduate 6 million students a year who use our software. We never charge students to use our software. So any student can use any of our software, doesn't matter how expensive it is, for free. Because it's just we're not in the business of making money off students. Further, we would like them to eventually become professionals and then pay for the software. So we do it for good reason, is what I would say. Got about 9,000 employees in the company. We distribute our software through channel partners, about 3,000 channel partners worldwide. About 85% of our revenue comes from our partners, so third parties who sell it. We have a small direct sales force as well that calls on bigger companies like Nike or GE, et cetera. Okay? Now, we're in a bunch of different industries. I'll just talk about these quickly. The first one, the robot, is my industry, the mechanical design industry. We make automotive components, we design cars, we make industrial machines, things like robots. It's a big industry by itself. It's the biggest industry we're in. We do AEC, which means buildings and civil. So we do building design, we do roadway, rail, those sorts of things as well. We have a consumer division that has a variety of products, typically lower cost, designed to do things on a more casual basis than our professional students do. We also have a film and game industry. The picture in the lower right is from Gravity. A film like Gravity, they don't really put Sandra Bullock into a Jeopardy. They don't move her around like she appeared in the film. That's all special effects. That's all Autodesk that does that as well. So those are the industries we're in. We share technology across the groups. One of the big benefits is my mechanical design software uses the same stuff that was used to make Gravity. So we have such good images because we have a very demanding customer base across all those industries. So big picture, that's what we do. My industry, the mechanical design industry, we do things from concept to engineering, to simulation analysis, manufacturing, PLM, and data management. So we do the whole thing of early concept all the way out to manufacture, okay? So, and there's very different engineers involved in those processes. So in the early cycle, maybe if you're an auto company, there's a person who's more artistic and less of an engineer who designs. Later on, they get to be more mathematical and more engineering-ish as you move along the chain. So we have software that handle all pieces of those things. Okay, we're a very acquisitive company. We like to buy companies. So just in the last 6.5 years, we've acquired more than 100 companies, spent more than $1.7 billion. It's really what we do with our cash, is that we buy companies that we think would help our customers extend our portfolio. More than 50 related to the future of making things or the cloud. Delcam, for example, fits into this category. Delcam was all about future of making things, about shop floor, et cetera, to extend what we did there. Now, Delcam was an interesting acquisition. If you think about, do many of you know Delcam from before? So Delcam's well known in the manufacturing industry. What they're known for is really complex machining. They make molds and dies. They make this sort of stuff. Turbine blades, digital inspection. They make real complex stuff. Here, mill turn lathes, multi-axis machining. That's been their big thing. They're focused on additives, subtractive manufacturing, and inspection. So that's really what we bought, because it extended our future of making things. But we also found a really inspired little group that was focused on footwear. And they really had, their big focus was the manufacture of shoes. So it became clear to us as we got to know the people, got to know the tech, we saw a big opportunity to extend Autodesk technology plus Delcam technology, put some of these things together. We could do a great job on design through manufacturing of shoes. Delcam also had this really strong health business focused on things like orthotics. So, and the vision that they brought to us is that we can make beautiful shoes that are healthy for people, which is a great idea, I think. I hope it's feasible. I think we'll know as we move along. So Delcam does the whole thing, just like my business. They do shoe manufacturing, last modeling, concept, very high concept design, 3D printing of footwear, sales tools that let you automate the way you go to market with shoes, as well as foot health. So we're trying to integrate that whole idea together rather than having some of these things be afterthoughts. In today's world, you can't build a product and then figure out how to take it to market. There's lots of changes going on. In fact, I would say I've never seen as much change going on as going on right now. I think we're sort of in a manufacturing renaissance. In the United States today, people talk about high-paying jobs in manufacturing. Jobs are coming back onshore that people thought were lost forever. If you go to the universities, and I spend quite a bit of time with the schools, they're all scrambling to get things like NC machines back into schools because 8 years ago, they got rid of all these shops. They got rid of NC machines. They said, no one's ever going to make anything in the United States anymore. Now it's the exact opposite. People want to start with making it and go to the design it. So this revolution that's going on has been really fundamental in the business. Now, a big thing that's come out of is product innovation. I'll talk about this in a lot of detail. If you don't have the world's best product, you're just kind of screwed in the market. Product is king, again, is really part of the good news to me. Now, we call all this concept the future of making things, okay? Because we think there's a bunch of changes in the market that are driving this, and we're doing some things about it. So I'm going to try to tell you what the change is, what we're doing about it, then I'll try to relate it to footwear as best I can. Now, except that I'm an ME, I wear shoes, but I'm not a shoe expert. I have shoe experts on my team, is what I would say. So I have to trust in them. All right, so future of making things. A few years ago, manufacturing was all about product efficiency. You can think of it this way. Everyone wanted to be Dell computers. You wanted to make your machine in the most efficient way possible. Now, I've been to the Dell plants. They're in China. They're not in the United States. A Dell comes off the line every 6.5 seconds. Okay, they fill a 747 every day of just laptops from China to the United States. Okay, so it's all about efficiency. Okay, they wanted efficient supply chains. They wanted to make sure you could manufacture efficiently. So we offshored a bunch of things. We have all these kind of horrible things going on with plants offshore. So that's the old world. Now the new world's more like Apple. Okay, apples, by the way, are made in the same factory, but they take 3 minutes each to make because Apple pays attention to how does the product look. You have to put soft bumpers around the face of the apple so it doesn't get scratched. Frankly, Dell wouldn't care if it's scratched. That's not what you're buying when you buy a Dell. You're buying an inexpensive computer that works. You're buying a piece of fashion as well as something that's functional, when you buy an Apple. So the focus now has started to shift to product innovation. That's become the big things. And you see all sorts of different things. Ergonomic chairs, wearable devices, ergonomic cars. This actually is a Mercedes-Benz that's made of 100% recyclable materials. Headphones that not only work but have an attractive feel. This is a really interesting story. This actually was designed by one of our employees. It's called a Biolite camping stove. Okay, so it's a stove that burns 100% of the material, so there's no smoke. It was originally done because this young man went to Africa, found cooking fires are the #1 cause of death in Africa, and because they smoke. So he just came up with a product that didn't smoke. And he used our finite element analysis software. The heat of the flame drives a blower, which consumes all the material in there. Now, one of the extra outputs of this is that it generates electricity as well. So the device has USB plugs. So he now makes a device that you can take camping. $130 stove, you can put some twigs in there to make a fire, and you can charge your cell phone. Okay, so product innovation has become really the big thing. Certainly true in the shoe business and the whole wearable business. Now, manufacturing's also changed a lot. Okay, so this is the Airbus 350 fuselage. Okay, so it's produced with carbon fiber, so it's actually taped together. The machine you see there is an NC machine that lays 5-inch wide tape around the fuselage. So the fuselage comes as one piece. Now, the big gain is an interesting gain here, is that take the 787, it's a carbon fiber plane. It's woven, it's not stapled or not riveted together. A big difference it has is it has 1 million fewer holes in it than a 747 has. Okay, so, and if you think about every time people do something, they make 5% error. So 5% error with 1 million holes is a big problem, right? Particularly in an airplane. So the benefits are way beyond just the strength to weight ratio. So for the first time, what we see is manufacturing is starting to drive design. Our manufacturing people can design things or can make things we don't know how to design yet. Okay, carbon fiber is a great example. Nobody really knows how to use carbon fiber. You saw my picture of the car I just bought. I don't have it yet, is the truth. I've been waiting for a long time for it. It's got a lot of carbon fiber on it because it's a sports car, and they always worry about strength to weight ratio. The roof on it, the roof's what, about this wide, maybe this big? No, it's 6.5 feet wide. About this wide, about this one. Used to be made out of fiberglass. The old one weighed 74 pounds. The new one made of carbon fiber weighs 12 pounds. Okay, now remember, it's a sports car. 12 pounds at the top of the car makes a big difference. But the maker says it could have weighed 6. The truth is we have no idea how to design this thing. We just designed it the old way and changed the note on the drawing. It was all we knew how to do. So, and this is the truth of the state of technology. Technology is ahead of us today. So we have to find ways to catch up. And by the way, these are great designers. It's not that they're making mistakes. Nobody knows how to design carbon fiber. We have to experiment and learn. There's actually videos. You can go to Netflix and find a video on the i3, making the i3, which is BMW's compact carbon fiber car. It was trial and error. They had to figure out as they went. It's a pretty interesting little video about making that device. So there's some really new, interesting, disruptive trends going on right now, more than I've ever seen before. I won't be able to cover all of them for time reasons. I just want to cover a few of the interesting ones. So there's a few categories. One's product innovation. So this, I think, is the most important one. The convergence of physical, digital, and software. No products today only have physical elements. If you were going to design something new, if you were going to design a skateboard today, you would probably have it connected to the cloud so that you could gather data about your performance. How high was your last jump? You could track how far you went in each ride. There's all sorts of things you'd want to do. Everyone wants to design connected products. Even cows are connected these days, so we can track where the herd is. And there's this idea of lots of little bits of data rolled into big data. You can learn a lot of things about how things behave. Everything's becoming connected. And of course, there's the ridiculous example. There's the coffee cup that if you pour coffee into it, it'll tell you it's got coffee in it, or if you pour a beer into it. Okay, that's not really useful, but there's also some really good things. You know, devices like this that can tell the sanitation team when it's full, so come empty me. Okay, devices like this that can tell you the status of it. You can turn it on or off from your laptop. You know, I'm a Quirky user. I don't know if any of you guys are Quirky users, but you can control your whole home from your laptop today. Okay, just with very simple off-the-shelf devices. I'll tell you, the autonomous car is coming. You know, cars communicate not just with the road, but with each other. If you've ever been in an autonomous car, you'll find they drive far, far faster than you do, and they will scare you to death. Because when they go to intersections, they don't slow down, they just weave, right? So the time savings you can get out of these things is impressive, amazing, and will scare the crap out of you, you know? But it's just a future we're all looking at. So electronics is changing really everything about the way we design. A big product innovation. Now, by the way, CAD is not very good at this. My software is not very good at letting you design electronics, software, and mechanical systems. There's software good at each one, but none of them are particularly good at doing all of them together. Okay, so there's lots of good examples. The Nest is one of the most popular examples. You know, a much more intelligent connected thermostat, tracks when you're home, adjusts your temperature. My assistant just put a Nest in, saved 35% on her fuel bill. Okay, so there's some real savings of these things. Cars are hugely connected systems these days, and all factories are becoming highly connected, so we can monitor exactly what's going on in your factory with performance, et cetera. A great example of this is the Tesla. You may remember it's now I guess maybe a year ago, there was an accident with a Tesla. It hit something on a highway and destroyed the car. So the Tesla executives were worried, are our cars riding too low? They didn't really know, but so they raised all the Teslas in the world a ½ inch. Okay, they could do that because of connected software. The Teslas are all connected to the cloud. By pressing a button, they can say every car in the world goes up a ½ inch. So this is some of the, and you know, they weren't sure they had to. It turns out they didn't, but they still did, and they could. So the effects of these things are dramatic. Now there's also new manufacturing materials and methods. This is a particularly crazy world. There's more stuff going on in the way you make things ever before. Everyone knows the story of 3D printing, additive manufacturing. I think there's probably no overhyped, poorly used technology on the planet than this. So we have a pretty interesting point of view on this, which I'll talk about in a little bit. By the way, it's not about this nonsense, which this is the overhyped part. Everyone thinks about printing the same thing they used to print or making the same thing they used to make just on a 3D printer. There is no point in making the things you used to make using this methodology. It's just a slower, more expensive, less stable product. If you do something that's designed for it, then you can do something dramatic. So it's not about this. It's very much about additive for industrial. Okay, now the active component here, you see this little element there, okay? It's a lattice structure. Now that structure has as much strength as the old structure did, but weighs 15% of where the old element did. So you can get dramatically different strength to weight ratios using new methods like design methods like this, and use far less material. So big benefits if you start to design things different. Now, there's also really creative things. There's a company called Normalair. They're one of our customers. They were at our user conference recently. What they do is they make custom earbuds. So what you do is you take a photograph of your ear, your right and left ear. What they say is everyone's ears are different by 20%. And June, your ear is different than your ear. So these are earbuds that won't fall out when you run. Take pictures of your ear. Now the way they do this, they put a quarter near your ear so they can tell the size of it. And 2 days later, they'll send you a custom earbud printed that fits your ear exactly. You choose your color. They're downtown, they're in Manhattan, printing earbuds. Okay, now who would ever think Manhattan we're manufacturing, right? So that's the revolution that some of these new methods are causing. Now, there's also pop-up factories. So it's gotten to be very, very easy, I think, to build a new factory, custom designed to do exactly what you want to do. So there's some of these revolutions. I recognize I'm going a little fast here, but I have to. Now, there's also really new business models and new funding methods. You know, I think everyone knows about things like Kickstarter. small companies can do incredible things today because they can use the power of the cloud to project where they're going. So, in fact, if you're a big company, that's where the threat is from a competitor. With an innovative small company that got some quick funding and is able to do something really interesting quickly. Now, there's also new business models like power by the hour. Okay, now, if any of you fly international, and if you've been around as long as I have, you may remember the days where you had to have 3 jet engines on a plane to fly across the ocean. It was a regulation because the jet engines weren't reliable enough. Now you see planes like the 767, the 787, 750, these planes have 2 engines, okay? Far cheaper. And engines are more than $1 million each. They're typically $15 million each. They're not cheap, okay? So big savings if you can do this. The reason they did this is the reason they've become so much more reliable is a business model issue. GE, Rolls-Royce, companies like this, stop selling engines. What they now sell is power to the companies. So they sell uptime with their engine. So GE gets a direct benefit if their engines are online more often than they used to be. When that happened, GE had all sorts of incentive for the reliability to go up. It's what happened. So people are starting to sell things like, don't buy my engine, you buy the use of my engine. Okay, so you have an ongoing relationship with your customer after the fact, okay, which is a really desirable situation. You don't sell them something up front. You have a revenue opportunity for the long term with your customer. A pretty dramatic change the way business is being done. And it's surprising it changes the way products work as well. I think this is the last thing. There's also new team dynamics. Design used to look like this. When I was in my 20s, I worked in a room that looked sort of like this. There was a bunch of guys wearing white shirts in the same room. If this had been our design department, it would have been filled to the brim with guys wearing white shirts and ties, standing at their desk working. It now looks much more like this. One, you have a much more diverse population. It's not just engineers in a room. There's engineers, marketeers, salespeople. There's a diverse set of jobs working together, different points of view, and it's all distributed. You have people who are not in your office. The design teams are spread all over the world. So it means you need to have a very different design methods just to match the culture that's being executed on today. So these are the big disruptors. Focus on product innovation, new manufacturing materials and methods, new funding business models, and new product team dynamics. Now, my bet is you experience all these things yourselves in the footwear industry as well. You don't design in a silo anymore. You design with teams. You're looking at new materials. You're looking at new business models. All these things have changed, I think, greatly. So let's just talk about what we're doing about it. Now, many of you are familiar with CAD. You've probably all used CAD of some sort. CAD's kind of a pain in the behind in some ways. Okay, and it's because it's always been a little behind our customer needs. In the early days, this is what we did. We made documentation. We were absolutely great at making a mechanical drawing. Okay, we shifted to a world of optimization. We made a better product than you could make because we were able to make a model and analyze it. Okay, so you could come up with a lightweight structure like this, which might be difficult to conceive of and very difficult to do in this sort of formats because we could really analyze how the design worked. That was the innovation of 3D and modeling that did it. Now, we're starting to move beyond that today. You have things like design visualization, which can be really amazing. Now, you've all seen car commercials. I will tell you there's virtually no cars in car commercials. They are almost always digital cars. They talk about the $1 million shot where they have the Jeep on top of a mountain precipice somewhere. They didn't take a helicopter and fly the Jeep up there and drop it. It's a digital car. It's almost always an Autodesk car, by the way. So this image here, this is a pure digital image. Now this projector is not great, okay? So you can't see some of the detail of it, but you really have a world today where the image you get can be even more realistic than what you actually see in real life. And because of the speed of these things, you can look at many things real quickly. Audi, for example, uses our digital design tools. The board of directors look at the car designs every week, okay? And what they say is, you get a feel for the car based upon little design clues. If I can look at the car and look at between the seam, and if I see a bolt in there, it just gives me a different feel for the car. So the visuals are really, really important, but you need huge accuracy, huge performance to do this. Very feasible today to do in today's world. Now, the other thing that's going on in the car industry, which I think will happen here as well, light, which used to always be something that just was external that lit the device up, is becoming a design element. Again, if you look at Audis, you know how they all have the LEDs under the headlights? So it's a component of the design today. So light is a really important thing the auto companies think about how do I use design emission versus light absorbent to have a design clue. And I've got a little video here that will show you some of the ideas here. You can see you rotate the image and lights just span across it. So you can really understand what these things look like. So the use of things like LEDs, the real details of it, is very much changing the way people perceive designs and what they need to do with them. Okay, the other thing that's happening is simulation is becoming present throughout the pipeline. It used to be we designed something, threw it over the wall to an analysis department who did a real detail, close, precise analysis, and they said it's going to fail in these 3 places, or you're going to have this much drag. It would go back to the designer, they would do it again. It was this loop. So today these tools are being brought into the cycle. So this actually is a simulation of, it's a computational fluid dynamics simulation of air going across a car. This happens to be a Carrera that a designer could use. So it fits into the earliest concept of the car. So the same thing can be done with a shoe. You'll be able to analyze what's the impact if someone is stepping on the side of his foot or the front of his foot, et cetera. You'll be able to do that early rather than late. Lets you really compress what you have and lets you have a great design very early. Okay. There's also a new way to think about designs. If you design something like this, you don't design by yourself. You typically have the design and engineering department work on the model. It's consumed by others, vendors, customers, manufacturers, sales, et cetera. There's different operations and different tools that work on it, CAD tools, visualization tools, simulation tools. All these things are separate and work on them by different departments. Then it spreads out further by the phone, with tasks and meetings. All these things are separate. The new world that Autodesk is bringing with things like Autodesk 360, it brings all this together so everyone can access the same central model without having to worry about things like what's the file format or you don't have to publish it. The worst thing you can ever do is publish something, okay? Because once you do, it's no longer up to date. Okay, so this presentation that I was working on, this happens to be version 6 of this presentation, which isn't bad. Usually you get up to version 18, 19. So I've been collaborating with my Delcam team about this, and this morning Chris is saying, do I have your correct version? I don't know, do you? What version do you have? I've got version 5. Oh, I sent version 6 last night. Oh, I didn't get that. It happens all the time with designs, right? So it's because you have to publish this model. Only if you have a central database of intelligent information that everybody can access do you get it. Now, the other thing about data management, historically it had been very tech-centric. So the new tools, this is a tool called Studio Wall, which the auto companies are starting to use, that lets you manage your data in a portfolio type arrangement, which, auto designers are the same as you guys, they're designers, right? So they think about things as portfolios. So you're able to look at all the different sorts of assets in a portfolio type appearance to let you quickly go through all the design alternatives. Okay, I'll go through this one quick. The mechanical, electronic, software convergence. This is the hardest one of all. I will tell you, we don't really know how to do this one yet. We are working on it. What we see is that there is just disconnected design. Any product you make is going to have these different systems where maybe you have a hydraulic system, a mechanical system, an electronic system, software. They're all worked on by separate products, all disconnected. So if you're going to design something like this device right here, there's software in here, there's electronics. The guy who designed it gets it to work, and at the very end of the cycle, they bring all these different components together and see if it works. It doesn't, then they have to go through the whole debug process after you're finished with the design. That's a problem we're trying to solve. We're trying to bring it all together so you can simulate the entire system and determine how the whole system does. We don't have a great name for it. We sort of call it cyber mechanical. It feels a little Terminator 1 to me, but because there's really no concept for it. But we're trying to make sure people can simulate the whole system, including the software together. Now, team dynamics has changed a lot. CAD has actually really damaged team dynamics. When we brought all these nice computers in to help people automate, it's really narrowed their focus. They're crunched down looking at their screen, no longer talking to each other. That big room of the guys in the white shirts, they actually talked to each other a lot. So they had good collaboration. CAD's actually heard it. So our new generation of tools, the things that are out in the market today, have a collaboration pane built into them. You can think of it as this is Facebook plus CAD together is the new experience for our designers. So they're able to collaborate in an asynchronous mode. Because the other thing is no one ever wants to talk to each other anymore. If you call somebody, the worst thing that you want to have happen is have them answer. You want to leave a message saying, hey, I was interested in X, Y, Z, right? So what you want is asynchronous communication, where I can say, here's what's on my mind, and then they'll answer, here's what's on their mind when they can. So we've built that into our CAD system. Big, big change, I think, the way people collaborate. And of course, multi-device. Everybody's got a phone, a tablet, a computer, multiple computers. I don't know how many computers. I have 4 computers just in my office at work, as well as a tablet, and et cetera. So everyone does these things today, and we make it really easy to share that sort of data. You don't have to be a CAD expert as well, so we make it a lot simpler for the consumer as opposed to the designer. Now, I know this is getting long, but additive manufacturing is one of my favorite topics of all. I don't like the word 3D printing. I think it misses the point. Additive is what you're really trying to do, particularly if you can do additive plus subtractive together. And this is part of the key. If you were saying something about joints, yeah, so a lot of our customers in the medical business, these are knee joints. Okay, the idea of a product like this is that they're webbed so bone can grow into them, right? So this is actually an old-fashioned design. You wouldn't do it this way anymore. You would have a much finer structure. So what we're trying to do is let you do things like this. This is the new version of a hip socket, okay? So very fine structure, which bone is really easy to grow into. You have the same strength to weight ratio that you have today in a very different way. Now, what's interesting about this, no one would think about this. That first design, you can certainly think of that structure and have some holes in it. People think that way. They don't think this way. They don't think about lattices. So Autodesk has software that would let you take a design, maybe it's this thing here, and you can say, I've got 50 pounds over on this corner here, so redesign a lattice through it that supports that use model. So the design actually supports the use of the system. So here's a good example of this. If you see, here's a very industrial product. If you look at the lattice here, very strong and thick down here and gets progressively lighter up here. So as you put a load to this thing, it will adjust the lattice based upon how the product is used, as opposed to how just making things solid. So it's a really new way to think about things. Lots of methods going on here. You end up with design that looks much more like bone structure and much less like the physical systems that we're used to today. So it's sort of what I think of as the post-geometry era, where you don't have to design all the elements of it. You define the use of the product. It's going to be used this way. Here's kind of the loads on it. Now, system design it for me. It's all possible because the cloud gives you nearly infinite compute power. Here's an example of a chair we did. So, the traditional chair, we have 4 solid legs. We just told it we want to have 4 legs, we want it to be this high. We defined some parameters. We threw it to the cloud and said, you guys just go design this thing yourself. And it does an iterative process, basically evolves a design. So it comes up with a design, measures it, did it work, did it fail, am I closer or further away from the answer, and chooses that one and then moves on. So it goes through many generations, as you can see. So the design you get is just as strong as the old system, but infinitely lighter than the old system is. So this is the chair, all aluminum, but you can pick it up with one hand, and it's just as strong as anything. So very new ways to design. Now, footwear. Okay, so how does that apply? Sorry about all this, but how does it apply to footwear? So footwear has some really special things. One, you got to design something that has to really look beautiful. Footwear is not just about function. It is about function. It's got to work well, and it's got to be manufacturable. Dwayne and I were talking this morning. This is about design. It's not about art. Okay, which the difference is that it has to function. Now, there's an artistic piece to it, but it has to function at the same time. So Autodesk Footwear division focused not only on the design, which I think we do a really great job at that stuff. But we're trying to be sure we can do market. We're trying to be sure we do all the other things that we used to do. Things like visualize, make the last, make the molds to make sure that we can make the sole components of it so we can manufacture as well. We also are trying to help people sell their products. Now, I think I have a video. I have a little video here. So this is one of our partners made this video, which I think was really interesting. I'm going to play this thing. Okay, so, you know, with this, we can make it, you can design an element and very quickly look at design alternatives. So here he's going to just show a few of the different designs come up with and just look at different alternatives of it. And there's so much personality in each of these things. Okay, so I think he's going to focus on the little black shoe here. If you want to change materials, it's as simple as choosing a new material. You get a very different view. Even things like the shoelace can make a difference in how the shoe appears. So think about the modern shoe store. It's likely not to have this giant inventory of a bunch of shoes in the back room. It'll likely have a bunch of 60-inch panel displays around the corner, and the customers are interacting with their shoes online, deciding the shoe they want, and they say, that's the one I want. And then it's made, you know, over the next 24 hours. So you can really change the way you start to design and build these things. This video will go on for a while. You can see how it would apply, I think. It really lets you have a very different sort of world. So I think you can see that the future of making things is not just coming, it's here. Big focus on product design, product innovation, and new ways to do it. We have some really interesting software that help you do it. We are very interested in making sure that we do the same thing for the footwear business, therefore our footwear division. Thanks much, everybody. Appreciate your time.